So this lecture is on the basics of waves. We're just going to define the terms, talk about the wave equation, and then we're going to end with this key idea that the velocity of any wave is constant in a given medium. Okay, so starting with the term wavelength. So wavelength has this symbol lambda, and the definition for wavelength, if you look in most science books, it's going to say peak to peak or trough to trough. How many of you learned it that way? Peak to peak or trough to trough. On this diagram it says crest, but look, you could say wavelength is from peak to peak, right? Bam, that would be wavelength, lambda. Or trough to trough would also be wavelength, but I think the ultimate definition for wavelength, you say from one point on the wave to the next identical point. So that distance there is the wavelength. Oh, and what's the unit for wavelength going to be? What do we measure wavelength in? I'll give you a hint. It's a length. Meters. We measure it in meters. Okay, frequency. Next term on the list, frequency. Now, is frequency only a term that's used for waves? No. Frequency is anything per time. So it could be per second, per minute, per hour, per day, per year. In the summertime, what's the frequency that Spaldo visits In-N-Out Burger? I'll tell you. 2 times a week in the summers. Off summers, we're looking at like 2 times a month. Probably twice a month during the school year. Summertime, twice a week. Okay? That's a frequency. Okay? Frequency. So if you want to write a definition down for frequency, frequency is the number of times something happens. In physics, it's going to be per second. But outside of physics, you could be per minute, per day, per year, whatever. It's the number of times that something happens per second. Now, the unit for frequency, the unit is, it's literally per second, right? Per second, which is the same thing as 1 over a second. Anybody know what we call 1 over a second? The hertz, Hz, which is hertz. Okay? So frequency, so if you're talking about the frequency of a wave, it's how many waves per second. Generally, it's going to be a very high number. You know, especially if you're talking about light, you're going to be talking a very, very high frequency, many, many, many waves per second. Okay, velocity. Now, the velocity of a wave, let's look at this wave equation right here. So the velocity of a wave, it's how fast the wave moves, but it can be found by multiplying the wavelength by the frequency. Now let me show you why. So velocity equals wavelength times frequency. So what do we measure the wavelength in? Wavelength is measured in meters. And then what did we just say frequency was? Frequency is hertz, which is 1 over a second. What do you get when you multiply meter by 1 over second? You get meter per second, which is velocity. If you multiply the wavelength by the frequency, it comes out as velocity. Okay, next term, period. Now, we've talked about period before. In physics, is this something that only pertains to waves? Is period going to be only for waves? No, it's also for a pendulum, right? So if you're looking at a pendulum swinging back and forth, so like here's a pendulum like this, like connected to the ceiling like this. So this pendulum swinging back and forth, right? What's the period of a pendulum? It's the time for one complete there and back, right? That's the period of a pendulum. What else has a period in physics? Mass on a spring. So you got a mass on a spring, you set it in motion and it goes doing, doing like this. What would be the period for mass on a spring? The time for one complete doing, doing, right? Back to where it starts from. So for waves, what do we mean by the period of a wave? It's the time for one complete wave. Now, what are we going to measure period in? Period has a unit of what? It's the time for one complete wave or one complete cycle. So unit of what? Seconds. It's a time. The thing that I want you guys to see is that frequency, and this is really important. I almost promise you're going to see this on the AP exam at some point, whether it's multiple choice or free response. I want you to see that frequency and period are the inverse of each other. Frequency is 1 over the period, and period is 1 over the frequency. So I know most of you are like, what? Like you don't totally have your brain around it because it's kind of abstract. So look, here's a real easy way to understand it. I'm going to clap my hands with a frequency of 2 hertz. Ready? Okay, that was a frequency of 2 hertz. What does that mean? What does a frequency of 2 hertz mean in that situation? 2 claps per second, right? So Spaldo clapped his hands with a frequency of 2 hertz, meaning 2 claps per second. What's the period of 1 clap? If I'm clapping my hands twice per second, what's the period for 1 clap? Half a second. So notice that they're the inverse of each other. 1 over 2 is what? 0.5 seconds, right? Because this is 2 hertz, which is 1 over second. So that comes out as 0.5 seconds. You guys get it? Ready? One more. I clap my hands with a frequency of 4 hertz. Ready? This is harder. Takes a lot of training for this. Ready? 4 hertz. Okay, so that's 4 hertz. Are you videoing me? You were, weren't you? 4 hertz. So if I clap my hands with a frequency of 4 hertz, what's the period? What would be the period of 1 clap? 1/4 of a second, 0.25 seconds. All right, period and frequency are the inverse of each other. Next term, you got to know the amplitude. Amplitude of a wave. But before I explain amplitude, I got to show you what the equilibrium is. The equilibrium for a wave, if you draw a line right down the center of the wave, this line is referred to as the equilibrium position of the wave. If that wave died, like imagine it's an ocean wave, like way out in the ocean, like in a storm, the storm goes away, where's that ocean wave going to die to? It's going to die to the middle, and we call that the equilibrium. Now, the maximum distance, if you want a definition for amplitude, the definition for amplitude, it's the maximum distance from the equilibrium. So this right here is the amplitude of this wave. Amplitude. Right here, that would be the amplitude of the wave. Now guys, is amplitude a term only for waves? No. Let me give you an example. Mass on a spring. So here's a ceiling. There's a mass right here hanging from the spring. We set this in motion, right? So it goes doing, doing, like this. It's going doing, doing. Now look, what would the middle here be? That's the what? That's the equilibrium. Why is that the equilibrium? Well, if you think about it, at this point right here, look, you got mg down, you got force of spring up. Guess what these two forces are doing at the middle? They're canceling. It's the equilibrium position. That's why we call it the equilibrium position. You guys catch what I just said? Those forces cancel. That's the equilibrium. Now, what do we call the maximum distance on both sides from the equilibrium? That's the amplitude of the mass on the spring, right? Amplitude is maximum distance from equilibrium. Now, final thought is this, and we're going to use this idea quite a bit. The velocity of a wave remains constant in a given medium. So like you see that demo I have set up over there, that string? That string is a medium, right? The velocity of the wave on that string, if the density of that string is uniform, it's a constant medium, right? As long as the medium does not change. Everybody knows what I mean by medium? Yeah. Is it air? Is it water? Is it oil? Is it the ground? Like earthquake waves travel through the ground. Is it traveling through wood? Whatever the wave is traveling through, a string. As long as the medium stays constant, the velocity is constant. Now, what does that mean? So look at the wave equation. Velocity is wavelength times frequency. I'm going to show this to you right now today. So what we're saying is that this remains constant for a given medium. Okay? So what does that mean about the relationship between wavelength and frequency? If you crank up the frequency, what's going to happen to the wavelength? It's going to go down because the velocity stays constant. And then vice versa. If you lower the frequency, then the wavelength gets larger. You guys ready to see it? I'll show it to you right here. All right, but that concludes this lecture.